Okay, so today we are going to discuss about OSI layers. Like in our last lectures, we have performed networking devices, network topologies, what are the protocols, and another things that are used to start CCNA. Now, OSI is an important topic, but if you will check on Google, then OSI model is removed from 20301. But this is an important topic because if you know OSI model, then after that you can learn TCP IP model. So we will discuss this model. Okay. So OSI model is open system interconnect model. So OSI model is open system interconnect model. It is developed by International Organization for Standardization in 1974. Which is consisting 7 layers, and each layer has different but specific processing functions. So what is the meaning of open system interconnect? Like with the help of OSI, you can use any vendor of your router, your switch, or your device. So this is a common model, and this model is used to send complete the process of sending data from one location to another location. So we have 7 layer: application, presentation, session, transport, network, data link, and physical. So these are the 7 layer, and each layer has its specific processing function. Okay, so like you want to remember it by step. So just for the kidding part, we can remember it like this. Please do not take salesperson advice. Like just to remember this, I'm not against salespersons. Okay, so just to remember, like please stands for physical, do stands for data link, not stands for network, take stands for transport, sales, session layer, presentation, and application layer. So we have to remember this by layer to 7, layer 1 to layer 7, or you can remember it by top to bottom approach, like layer 7 to layer 1, like application, presentation, session, transport, network, data link, and physical. Okay. Next part is like application, presentation, and session are known as upper layer or software layers. Why? Because in these layers, all the work is done based on port numbers. Like in our last class, we have discussed about protocols, HTTP, FTP, SMTP, TFTP. They all protocols have some port numbers. So port numbers are not like hardware part. So that's why these 3 layers are known as software layers. After that, transport layer is there, which is known as heart of OSI. Like in our human body, heart work is you have to pump the blood. Like in our human body, heart is used to blood pumping. Same as transport layer is used to transfer data from top layer to bottom layer. Top layers are upper layers, application, presentation, and session. Bottom layers are network, data link, and physical layer, which are known as lower layer. So transport layer is used to transfer data in between upper and lower layer. And at last, what are the lower layers? Lower layers are network, data link, and physical, in which direct access of hardware device is included. So we have to explain each and every layer in detail. So let's start with my layer number 7, which is known as application layer. So application layer is responsible for providing networking services to user. It is also known as desktop layer, and identification of services is done using port number. Now come to the point. The first line is application layer is responsible for what? For providing networking services to user. Now, what are the networking services which application layer provides to user. Okay. And also they told identification of service, that network services which application layer provides to user is done using port number. And ports are nothing but socket, entry and exit point of layer. So total number of ports we have, in our last lecture, we have also discussed in protocol lecture that we have total number of ports 0265 535. And from that, reserve port 021023 and rest ports are open 1024 to 65535. If you want to check the complete port detail, you can Google like list of TCP and UDP port numbers. They will let you know about complete port numbers like 0265535. So again, come to the point, what are network services? So the protocols we have discussed yesterday, yeah, in last class, that are known as our services, network services. Now, for example, I'm taking an example here. One client wants to access web server. For example, this client wants to access facebook.com. Okay, I want to access facebook.com. So by default, you can check HTTP or HTTPS is used to connect with web server, hypertext transfer protocol or hypertext transfer protocol secure. So there is a HTTP request from my client to web server. So it sends the request to web server. So now Facebook is a server. Now daily users in lakhs, in crore, they are sending messages to Facebook. So Facebook web server receive the request on port number 80. If HTTP protocol is used, then it receives on port number 80. If HTTPS is the port protocol, then 443 is the port number. So HTTP request listen on port number 80. So this is sending HTTP reply to the client. If reply comes there, then you can check Facebook will open. So I have used my own Facebook screenshot here. Okay. Let me tell you another example there. Like for example, clients want to access FTP server of Microsoft. So ftp.microsoft.com. Same client sends the message to FTP server. Now the protocol is FTP, so the port number is 21. So I'm not letting you know about protocols. I'm just telling you about how application layer work. So if we have so many network services like HTTP, FTP, SMTP, Telnet, TFTP, and another network services. So application layer listen that request on port number. That's why it is known as software layer also. Okay, so this is the part of application layer. Now, when the data goes from layer 7 to layer 6, so it comes with port numbers. Port number 80, 21, 25, 53, 67, and 69. Okay, now what is the meaning of presentation layer? That we are going to discuss. Yes, data comes from application layer to presentation layer. Now, what is the meaning of presentation layer? So presentation layer is responsible for converting data into standard format. Now, which data and which standard format? Now, like, for example, I want to send any file with you, like on application WhatsApp. So you can check directly yesterday or day before yesterday, I send you file on WhatsApp that is 74 MB, I think. So I have compressed this file into RAR and after that I send it to you. Same as on presentation layer, it converts the data first and after that into standard formats. The example of presentation layer like ASCII codes, ABCDIC, JPG picture format, MP3. Like for example, you are downloading a song from website, then that song, it is in MP3 format. If you don't have MP3 player, then you are not able to run that like application or song. So the example of presentation layer is encoding, decoding, encryption, decryption, compression, decompression. Like you can say presentation layer provides security between two ends. Okay, so after application, presentation layer work is to provide security. When the data comes from application to presentation, after that data comes to session layer. So session layer is very simple. It is responsible for establishing, maintaining, and terminating session. Like for example, I'm taking your class. So our class time is, for example, 11 a.m. So I have started the session at 11 a.m. This time we both are maintaining our session. Now, for example, my session will end at 12 o'clock or 11:40. So that is your terminating session time. So session layer is responsible for when the session is established, maintained, and terminated. Session IDs work on session layer. So the example of session layer is remote procedural call, SQL, structured query language, and network file system. Session layer, you have seen that example somewhere when you are going to deposit money online, then there is a window for OTP. That window is properly for like 100 seconds, for 60 seconds. That is like a session. So session layer is the main layer who is responsible for establishing, maintaining, and terminating your session. So these are the part of upper layer. Upper layers are software layers because they are not directly connected with any hardware device. So let's move on to next layer, which is very important in our OSI. The name of that layer is transport layer. This model is very important before CCNA because in CCNA, we have to work on router, switches, firewalls. So we need to know about this, like on which layer routers are used, switches are used, as well as another devices are used. So that's why I'm letting you know about transport layer now. Now, transport layer is responsible for end-to-end connectivity. It is also known as heart of OSI, as I already told you. Now, transport layer has so many tasks which have to perform. Like transport layer is the layer which is used to identify the services. It is used for multiplexing and demultiplexing. Transport layer helps you to segment your data, sequencing and reassembly, flow control, and at last, very important, error correction. Transport layer is used for error correction. And I want to let you know one important thing. Error detection is done at data link layer. We have to discuss data link layer. Like if any error is detected in our data, then that can be detected on data link layer, but that can be corrected on my transport layer. Okay, so the first part is identifying services. So we know that in services, we have so many protocols, HTTP, FTP. So how to identify services? So simply they have divided it into two parts, TCP and UDP. Maybe you have learned these things in your academics, like what is TCP and what is UDP. So TCP is a transmission control protocol and UDP is user datagram protocol. Now, difference between both is TCP is connection oriented and UDP is connectionless. What is the meaning of connection oriented and connectionless here? Connection oriented means if I'm sending data to my destination, first I will check the path, that path is clear or not. Then I will get acknowledgement from the destination. After that, I will send my real message to destination. But in connectionless, they directly send the data. There is no acknowledgement in UDP. So TCP is a reliable protocol, but UDP is unreliable. Yes, in TCP, it checks the path, it will wait for acknowledgement. So it is a slower protocols, but UDP directly send the data, so it is very fast protocol. TCP is reserved with port number 6, UDP is reserved with port number 17. Now, the example of connection-oriented TCP protocols are HTTP, FTP, and SMTP. While UDP examples are DNS, DHCP, and TFTP. So, when we will discuss practically DNS and DHCP, you will get to know that in DHCP, it is used to provide automatic IP address to your devices. So, it is working as a UDP. So we will discuss that example in our practical. Let's move on to next part. This is the example of multiplexing and demultiplexing. How? Because the meaning of multiplexing and demultiplexing is one-to-many transfer and many-to-one transfer. So this is the data transfer process. Like if you are learning from layer 7 to layer 1, then many-to-one protocols, like now we have discussed in previous slide that HTTP, FTP, SMTP are the member of TCP, DNS, DHCP, and TFTP are the member of UDP. So if we are saying one to many, TCP to many protocol, and if we are saying many to one, HTTP, FTP, SMTP to TCP. So that is multiplexing and demultiplexing example. Okay. So the main part of your transport layer is segmentation. For example, this is my PC A and B is your PC. So I want to send hello, how are you to you. So transport layer, divide that it into segments like hello, how are you? Question mark 1, 2, 3, 4, 5. And after that, segmentation. For example, A sends data to B, hello, how are you? Question mark. But B receives on its end, you, hello, how? Question mark are. It is just an example, like my sequence is not good. So transport layer is used for sequencing and reassembly also. It will add number system with each segment. And after adding number system with segment, it will automatically rearrange the real data. And sometime when A sends data to B, I'm just taking an example. Sometime when we send the data, then sometime one segment is due to my internet connection, due to some any connection. Okay. So if my segment is missing, then transport layer is used to correct the errors. So transport layer has so many works. Now, what is the flow control process in transport layer? For example, A wants to send data to B. So this process is known as windowing process. That's why it is not like writing segments. It is writing A sending 3 windows to B. Like you can understand it like A sends 3 packets to B, 1, 2, 3. So if B receive this, then we can say at single time, A can send 3 windows to B. Now, acknowledgement is there. On the next time, A send 5 windows to B, like 5 messages, 1, 2, 3, 4, 5. But B receive only 4. So what is the meaning of this process? Like when 3 sends, 3 receives. When the 5 send, 4 receives. It meaning is PCA can send 4 segment at a time to PCB. Okay, at like we have to discuss how many segment at one time PCA can send to PCB. Okay. Now when data comes on transport layer, then there is one header attached, which name as segment. So we on transport layer, we have to say segments to data. because we are not on network layer, we will say it packet. On data link layer, we will say frames. So the PDO of transport layer is segment. Next part is hardware layer, network layer. Let's come to the point of network layer. Network layer is responsible for providing best path. Now understand this layer. Network layer is responsible for providing best path to data. Best path to data to reach destination. So network layer is very important layer because it is actually used to transfer data from one source to one destination. So on network layer, we have to work on logical addressing. Like our next topic is LAN and WAN. In that topic, we have to discuss network ID, host ID, what are IP addresses, and another things in our network. So device working on network layer is router, but network layer is divided into two parts. Like in our last class, we have discussed about some protocols. Okay, so same as network layer have some protocols. One part is the routed protocols, ROUTED, and one is the routing protocol, ROUTING. Now, what is the difference between routed and routing protocols? The difference between routed and routing protocol is simple. In routing protocols, we have to transfer data from one portion to another portion. You can say from one PC to another PC, you have to send the data that is routed. So how we can send data from one PC to another PC? With the help of IP address. IP address is your logical address. So if two PCs have IP address, then easily I can transfer data. For example, I want to send any letter to you, Dario. Then I will check your address and I will write my address on that letter. So that postman will help you to reach the letter. So routed protocol used to transfer the data traffic, but routing protocol actually used to transfer the data as well as best path to data to reach destination. So in CCNA, you have to discuss about these protocols, OSPF, EIGRP. In CCNA 200.301, now RIP and IGRP are not used, but we will discuss it. So example of routed protocol is A wants to send data to B. So my IP address is 192.168.1.1 and 192.168.1.2 is your IP. So I'm sending hello, how are you? So this is like a packet. Segment is your hello, how are you? So we add that segment and we write source address and destination address. So A send data to B. When B receives that letter, he open the letter and segment is there. So very simple process. Now same as a routing protocol works like you want to access facebook.com. Now you are sitting in India. Okay, Facebook server, it is in USA. So we have so many routers are connected between India and USA. So when you request to access the Facebook, then routing protocol automatically choose the path on the cloud. So that routing protocols help you to connect with your web servers, with your any another servers. So after this, when segment comes to network layer, one header is attached of network. So that's why we are saying it packet. Now come to the next layer. But before that, understand the concept on network layer. We have hardware device router. In CCNA, we have to work on this. Data link layer. So data link layer is divided into two sublayers, logical link control and MAC address. Okay. So logical link control is like a WAN protocols like PPP, point-to-point protocol, HDLC encapsulation, frame relay. Frame relay is your packet switch technology, which is used to connect with same network. That's why it comes on data link layer. So we will discuss it later in practicals. That part of MAC address is media access control. When we have discussed network devices, I told you about MAC address. That MAC address is the media access control address. It talks about physical address. Physical address is like it is permanent address. It is 48-bit address and 12-digit hexadecimal number. It is used for error detection. So how to detect the error in computer systems? So at data link layer, we are using switch bridge. But before that, we have to check how to detect the error. Same as the packet is there. That packet is now added in another packet, and source MAC and destination MAC is there. So at data link layer, one process is used, CRC, cyclic redundancy check. So it will add one number with this, like A is adding one number on its frame, and after that it's sent to B. If the number is matched on BPC, then the packet is good reached. If the number is not matched, then the error detected. So if the error detected, it shows that PCA CRC number is this, PCB CRC number is this. So that's why error is detected. For error correction, contact source transport layer. I told you error correction is done at transport layer. So it sends data to A again. After that, it sends data again to A to B. Again, it sends with the number. Now number, I have to check on B. If the number is matched, then the data is processed. Otherwise, it will continuously again and again and again data can be sent. So this is your data link layer, and it is the only layer which is adding header and trailer both on the packet. And this process is known as framing process. So switch is used on data link layer. So at physical layer is responsible for electrical, mechanical, or procedural checks. Data will be converted in binaries, 0 and 1. Like every network engineer before entering in this field thinks that he have to work only on cables, like devices. So he or she can think about only physical layer. Like physical layer is the work of cables, hub, repeater, and modem. Like if you are talking about switch, then you are L2 engineer. If you are working on routers, then you are layer 3 engineers. And after that, you can work on layer 7 also if you're working on application layer. So in cable part, like in physical, we have coaxial cable, twisted pair cable, and in the form of light, fiber optics cable is also there. So every data is sending in the format of 010101. That is done. So this is the process from application to physical. Now we have to check encapsulation and de-encapsulation, like properly how data sends. So data sends from application to presentation like this, the complete process that we have read until you can check. Now, when application to physical data is done, again physical to data link layer is there. Then the reverse process is there. And after that, data can be sent. So at last, we are going to discuss about the comparison between OSI model and TCP IP model. Okay. So nowadays, OSI model is not used. TCP IP model is used. So application presentation session is divided into one layer application. Transport layer is common. Network layer is renamed as internet layer, and data link layer and physical layer are divided into network access. So nowadays we are not using OSI model, we are using TCP IP. So the work of application presentation and session are done by application layer only in TCP IP model. So it's done. This is OSI model, because if you know OSI model, then easily you can understand TCP/IP model. So thank you so much. This was our topic. Next, we are going to discuss in our next video. We are going to discuss about LAN and WAN as well as IP addressing. So thank you.